Alrighty guys, one last one for you. Now this one's a little complicated for one major reason, and that reason is that water in this particular case is not actually your solvent. Most of the time, 99% of the time, we use water as our solvent, but in this case, we are not. We are using alcohol. And I've just realized that I miswrote something there. No big deal, I can fix it. But most of the time, water is what we are putting things in, but in this case, water is actually a reactant, you'll notice here, and so we're using our solvent as alcohol. So just keep that in mind. It really doesn't have much to do with anything besides that, but alcohol is our solvent here rather than water. Now, what I've got here is I've got a substance which is a cobalt compound. And this cobalt compound, depending on what it is bonded with, it changes color. If, like it is right now, it is bonded with some chlorines in order to create this complex tetrachloro-cobalt 2-ion complex that is here, it is a blue color. However, if I force those chlorines away by adding in waters, I can turn it into a purple substance here, which is a hexaaqua cobalt 2 ion complex that is right there. So how then am I going to get this blue color that I see here over here to turn into the purple color? Well, I'm going to adjust it using Lechat's principle. So Lechat's principle says that equilibria resist change. Whatever you do to a system, it's going to try to undo. So watch what's going to happen. I'm going to just go ahead and add some water. And by adding in water, it's going to make the amount of water go up. And by making the amount of water go up, it's going to say, you know what, I don't want all this water you gave me. I'm going to try to go to the side that doesn't have the water on it, and that's this side over here. It's going to go to the opposite side. Remember, when you add, it goes to the opposite side. So by adding in water, it's going to try to get rid of the water by going to the opposite side, and we should see a change from the blue color here to the purple color over here. So here we go. Here is some of this. Here is just some regular old boring, nothing special about it, water. And we can see that it has turned to the pink or purple color, as we can see there. All right. Now, how am I going to get it back? How am I going to get it from the purple side over here to the blue side? Well, the easiest way to do that is to add something that has chlorine in it. So let's go back with that hydrochloric acid that we have been using. And if I add HCl, then that's going to make this go up. And if I give it this chlorine, once again, equilibrium has been reestablished now. It's happy again. It's going to say, no, God, I just got happy. I don't want the chlorine anymore. I want to get rid of the chlorine. How does it get rid of the chlorine? It goes to the side that doesn't have the chlorine on it over here, because the chlorine is now trapped within the cobalt compound over here. And we should see the blue color increase, the pink color decrease. As I add, it goes to the opposite side. So here is some hydrochloric acid, this guy here, and you can see I can get this to go back to the blue or the purple color if I add in the HCl, like so. So if I add water, it'll go to the pink side. If I add hydrochloric acid, it'll go to the blue side over here. And I can make it go back and forth at my leisure. So add in a little bit more water, and I can turn it pink, like so. So by adding, it makes it go to the opposite side. Now, one trick question here. What's going to happen if I add in silver nitrate to this? What's going to happen if I add in silver nitrate to one of these guys? Now, at first glance, like a lot of the things that we have examined in this class, silver nitrate does not appear to have anything that is involved in this equation. It's got the silver ion and it's got the nitrate ion. So silver nitrate does not appear to be involved. Silver is not in anything that is here, and nitrate is not in anything that is here. So at first glance, it appears that silver nitrate will have no effect because neither of these species are involved in what's going on here. But there's a trick. And the trick is that chloride really likes silver. Chloride ions and silver ions like to get together to form silver chloride. So check out this reaction. The chloride ions like to react with the silver ions, and if they do, the chloride and the silver go together to make solid silver chloride. So by adding in silver nitrate to this, the silver is going to go after and hunt the chloride ions and take them away and turn them into solid silver chloride over here. Much in the same way that when we did our water reaction, the H2O was formed by creating the H and the OH that was there. So remember this guy here? If I put H and OH in the same space, they like to create H2O. So even though one of these guys might not technically be involved in my equation, I can affect it by adding the other. So technically speaking, silver is not involved in this equation, but by adding silver to this, the silver will hunt out the chloride and it will form silver chloride. So what's that going to do? That's going to make the amount of chloride go down. So what then do you think we should see? We should see two effects from adding silver nitrate to this. We should get a color change and we should get a precipitate. So if I add in some silver nitrate here, we can see that it turns pink and it turns cloudy because I am adding in the silver. The silver is hunting out the chloride. It is making the amount of chloride go down. So the chloride is decreasing. The equilibrium says, wait a minute, where's my chloride? You took all my chloride. So it tries to get that chloride back. So it goes to the side that has more pink on it. It uses up the blue, makes more pink, and it turns cloudy because we are making solid silver chloride here. So that's the effect that we see right there. All right. One last thing, and we're done. We can determine if this is an endothermic reaction or an exothermic reaction. Remember, we talked about this already. It's either going to be endo or exo based upon where heat goes. So if heat goes over here on the left-hand side, then it is considered to be an endothermic reaction, and delta H is going to be greater than 0 if heat is on the left-hand side. If, however, heat is a product, then it is considered to be an exothermic reaction, and delta H is going to be less than 0 that's there. So how can we tell? Well, heat is either going to be over here or it's going to be over here. Well, if it's over here, what would happen if we heated this system up? We would heat the system up. It would try to get rid of the heat by going to the opposite side, and it would turn pink. If heat is over here on the product side and I heated it up, then it would try to get rid of the heat by going back over here to the blue side. So here I have one pink and I have one blue. I'm going to put both of these into hot water over here, and we are going to watch to see what happens. Here is my hot water bath again. I'm going to take the pink and I'm going to take the blue and I'm going to put it in, and one of them should turn into the other color. Either the pink is going to turn blue or the blue is going to turn pink. One of them is going to happen and the other one won't, because it's going to shift the reaction to one side. So it really looks like the blue is staying blue and getting bluer, and it really looks like that pink that's over here is turning blue. So by all accounts then, by heating it up, we are sending it to the blue side of the reaction. So the pink is all gone and the blue remains. So what does that tell us? By adding heat, we have gone to the blue side. So over here, it must be that it is an exothermic process, because by adding heat, I went to the blue side, so heat must be a product. If heat was a reactant over here, then when I put those guys into the hot water bath, then they would have turned pink. the pink would have stayed pink and the blue would have turned to pink, but that's not what happened. What happened is I put them both in and the blue stayed blue and the pink turned to blue. So by adding in heat, it went to the opposite side. So this must be an exothermic reaction where delta H is less than 0.